All right, welcome to your lesson on the tree cookies lab. So tree cookies, they're round, they're full of fiber, but unless you're a termite, you can't eat tree cookies. So tree cookies are just simply a cross section of tree trunks. So if you're doing forestry work or studying trees, you can use these to learn things about the history of a tree. Each layer, meaning each ring on the tree, tells us a little something about the tree's life and the climate it was growing in at the time. So parts of a tree in cross-section, we're going to start with layer 1 over here, and that's the cambium. It's a layer of cells that's just one cell thick, and it's just inside the inner bark, and this is where new growth happens. So the cambium produces both xylem and phloem cells, which we'll get to, and this is where the tree grows outward from. So number 2, this is the phloem or the inner bark. This layer carries sugar made in the leaves or needles down to the branches and trunks of the roots where it's converted into food the tree needs for growth. So phloem, even though it starts with a P, kind of sounds like F. So phloem transports food, essentially, or transports the sugar made in the leaves through photosynthesis that we talked about earlier this year down to the roots. Number 3 here is the xylem or sapwood, and this layer carries the sap, which is water plus nitrogen and mineral nutrients, back up from the roots to the leaves. So xylem, X, is kind of close to W in the alphabet, so you can remember xylem transports water. And the sapwood is the light colored wood, and that's what gives the tree its strength to stand up to things like wind. Number 4 is a growth ring. It has 2 portions. It has a lighter portion. The inside of it is the lighter portion, and that is the early wood or the spring growth. And then the darker portion is the late wood or summer growth. And so those together represent 1 year of growth for a tree. Number 5 would be the heartwood. This develops as a tree gets older, and it's old sapwood that no longer carries sap, and it helps to support the tree. It typically has a darker color than sapwood since the water carrying tubes get clogged up, and this young pine tree on the right doesn't really have heartwood yet. Then the outer bark is the dark layer on the outside of this tree, and it is a protective barrier for the tree, sort of like your own skin, that protects the tree from insects, disease, heat, and cold, and other injuries. So on the next 2 slides, there's going to be a couple cookies. Try and predict how many rings there might be on them. They are about the same size tree, but the question is, are they the same age? So your first tree is this one. And so we can count the rings on this one. So we can start here, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this year's growth makes 13. So this tree would be 13 years old. Do you think this tree is older or younger? So this is going to be an older tree, and it definitely has tighter rings. I will give you a chance to count those. You can hit pause on the video to count them. So how do you think, if those trees are the same size and diameter, and the second tree is clearly older, what could make for those differences? Why is the second tree older and only as big as the first tree, which is only 13 years old? Well, tree cookie 1 has a lot of wide rings, and so it's a young tree that grew in an area where it didn't have much competition for its resources, so it probably had access to sunlight, water, nutrients, and space. So it was able to grow quickly and put on lots of sapwood each year. Tree cookie 2 had more competition, so competing for those resources such as water, sunlight, or nutrients, or even space. So it didn't put on as much sapwood each year. Also, the rings are offset. Notice that this right-hand side is thinner than the left-hand side. and this indicates that it either grew on a slope or had to grow around some sort of obstruction. All right, so thanks for watching the lesson on tree cookies. At this point, you can go ahead and try and start the lab, and shortly, please join us for the video call.